Okay. First step, go over all of the parts so we know we're talking all the same thing. Resistance, going to be measured in ohms. E is going to represent the voltage. I is going to represent the current measured in amps. And P is going to be our wattage. Because we've only got one path for everything to flow through, it's a series circuit, 120 volt source. And we're going to basically solve for every variable of each of the resistors. 3 rules for series circuits. The sum of the voltage drops is the sum of the voltage supplied, Kirchhoff's voltage law. The current is going to be constant throughout the circuit. And then the resistance is adding up. So just simple addition. The formula is going to be RT equals R1 plus R2 plus R3. So first step, simplify the circuit by adding all of the resistors. And what I do is I redraw the circuit again. That way I know exactly the steps that I've taken. So we take 70 plus 85 plus 40, and we end up with an ohm value of 195 ohms, and that's going to be my resistance total. The voltage, we simplified it. The voltage is the same, didn't change. So I have 120 volts. Now to find the current, you got to go back to using Ohm's law. So I'm going to try to keep all the formulas right here. E equals I times R is Ohm's law. P equals I times E is Watt's law. With basic algebra, you can substitute and solve for them, or you can use the Ohm's law chart on the front of the Uglies book or the one out of our lecture book. But if you're trying to find for the current, you can modify this particular formula and you end up with E divided by R equals I, or the voltage divided by the resistance equals the current. So we have 120 volts divided by 195 ohms. And for our current, I get 0.615. It keeps going, 6153846. But just to display, so we all use the same numbers to the thousand, it's 0.615. Now you're going to figure out your wattage. Wattage, P equals I times Z. 0.615 times 120 equals 73.8 watts. Would represent the total wattage of that circuit. Now that you've solved and you have your total resistance, total current, total wattage, you can work your way backwards and apply the rules of Ohm's law. Current is constant. So we take the 0.615 and we add it to the current. 0.615. Add it in for our current. 0.615, and we put it in our current. If you've got 2 of the variables in your formula, you can always force that third value out. How do you find E? E equals I times R. So to find E, we got 0.615 times 70. 0.615 times 70 equals 43.05. To find wattage, P equals I times Z. So I 0.615 times 43.05 . 26.476, and I rounded it because it was 0.4757. Because this is greater than a 5, we cross it off, and then we turn the 5 into a 6. So that's where the 0.476 came from. And we do the same process for each of the resistors. Yes, sir. No.
Could you write the math on the simple form?
On which one?
The simple form, where you got 195?
Oh, up here?
No,
How I
yeah.
got to the 195? You got it. It's right here. So your RT equals R1 of 70 plus 85 plus 40 equals the 195.
Okay.
Good catch. Thank you. I want to try to get as much of the how I got it up here so that way you can study outside of here. So the E, gotta look at it, I times R, so 0.615 times 85. 0.615 times 85 equals 52.275. 52.275. Now we're going to calculate our wattage. Wattage equals the amps times the volts. So we got 0.615 times 52.275. And we have a wattage of 32.149 rounded. Same thing here, I times R, 0.615 times 40. $24.6. P equals I times E, 0.615 times 24.6. $15.129. Now, once you've solved everything that you're going to be for your circuit, time to check our work. So we could apply Kirchhoff's voltage law, 43.05 plus 52.275 plus 24.6. We end up with 119.925, and we're trying to hit 120. Knowing that we have small rounding errors, you're off by 75 thousandths of 1 volt. I feel confident that you can attribute that to our rounding because we've cut those numbers off.
What were the numbers that you added together? I'm sorry.
All of the voltages.
Okay.
So you add all of your voltages, and then you check it to what your source is going to be. If you added it up and you ended up with 95 volts, then that should be your indicator. Hey, there's something wrong. Where did I make a mistake? And then you could work your way back through it. But if you're adding them up and you're off by 75 thousandths of 1 volt out of 120 as a percentage, that's pretty accurate. And then you do the exact same thing with your wattage. So you add, I'm going to do stars for this one. So we do a star for that wattage, star for the wattage, star for the wattage. 26.476 plus 32.149 plus 15.129 equals 73.754. And our total that we said was 73.8, so we're at 73.754. We're off by 46 thousandths of 1 watt. Knowing that we're rounding it, I would feel very confident saying we got everything right on that particular math problem. Like I said, if you come up and you only got 50 watts, and you know that the total was supposed to be 73, that should be your indicator. Hey, I made a mistake somewhere. Let me go find my mistake. If you draw each of your steps, make one change, make another drawing. Make one change, make another drawing. And you get into that habit, as the problems get longer, it's not bad because when you make a mistake, you just go one picture forward. when I went through my program, I tried to do a lot of it, and I'm not going to draw all the steps. Just do the steps. I learned the hard way. I was stubborn. I wish I would have just started that way, because you work on something for 34. This is very basic circuit, right? We don't have to do multiple steps. When you have large combination circuits, you work on them for 30 minutes and you made a mistake and you didn't do every step. I got to start all the way over. Make a change, make another drawing, and then keep everything as legible as you can. So just like how Robert said, how did you get that? Draw how you got your totals. That way you know exactly what you did or how you got the voltage. I times R. So you're just literally plugging them in. Keep your formulas that you're going to need readily available, and then just have those, all the rules memorized, so that you can solve the circuit. It'll make it much easier for you if you do it that way. So questions on our first series circuit that we solved? Or do we feel pretty confident with it? Or any questions with it?
I'm saying I feel confident with it, but it's starting to make sense now.
Once we do a couple, we'll do like 3. I'll break it into each individual one. That way when you leave, you can make some more of them up, and then you could see the steps won't change. You're just going to change the numbers. So then this will give you a good step 1, 2, 3, 4, like how we did next door. Okay, then I'm going to erase this one, or not erase it, shut it off.